Yes.
Okay, great. Well, hi guys. Today I'll be talking about data warehouse. We saw data lakes until now and a few points about data warehouse. So let's dig into it and see what exactly this is and get to know more about it. Now, um, the first point there you see is it's a no garbage data. You can't use all the data into it. It means you might load the data into the data warehouse only after you have a schema clearly defined and uh, and you have a use case identified. So it means no garbage data in the data warehouse. So you might take the raw data, okay, that exists in the data lake. What we do is we transform it and we organize it, so maybe process it, and then we clean it up, and then later we store it, so it can be used immediately inside of our warehouse. So well, maybe because the data in the data warehouse is used to generate charts or reports, dashboards, or has a backend for your machine learning models. Okay, so whatever the use case for your business is, that data is immediately be able to use from the warehouse, unlike data lake. Now the idea is that because the schema is consistent and shared across all the applications, someone like say data scientist or data analyst could go right in and derive insights much faster. So a data warehouse tends to be structured and semi-structured data. So that's organized and placed into a format that makes it useful for immediate querying and analysis. Okay, now say the data warehouse should consolidate data from many sources, right? So it imposes a schema. Now, a data lake is just like raw data, but in a data warehouse, it has data together, which makes it available for querying. All right. And so now, to use a data warehouse, an analyst needs to know the schema of the data. So that becomes very important. Okay. Now, another reason to consolidate um, all the data besides standardizing the format and making it available for querying is to make sure the query results are meaningful. So you want to make sure, the data is clean and accurate and consistent. Okay. Now, next point is the data in the warehouse should have a quality, consistency, and accuracy. Now, the purpose of a data warehouse is not to store data. That's the purpose of the data lake. If you have raw data that you want to keep around but not necessarily query it, don't bother cleaning it or streamlining it. You can just leave it in data lake. So all data in a data warehouse should be available for querying, so that it's important to ensure that those queries are quick, and you don't want people waiting hours or days, right, for the results. So the data warehouse should be optimized for simplicity of access and high speed query performance. So this is the purpose. Later, now we'll see what is a modern data warehouse. Okay, now we described, data warehouse and how it's different from data lake, right? So now what makes a data warehouse modern? Now, business data requirements, these, it continues to grow, right? And you want to make sure that a data warehouse can deal with data sets that don't fit into memory. Now, you don't want separate data warehouse for different data sets, right? So instead, you want a single warehouse that can scale from gigabytes to petabytes of data. And you also want it to be serverless and fully no ops. You want to focus more on your business, and you don't want to have any operational involvements there. Okay. Next is your data warehouse is not productive if it allows you to do queries but doesn't support rich visualization and reporting. So ideally, data warehouses can seamlessly plug in to whichever visualizations or reporting tool your business most familiar with. Okay. Now, similarly, because the data warehouse requires a clean and consistent data, you will often have to build data pipelines to bring data into warehouses, right? Now, the modern data warehouse is able to integrate with an ecosystem of processing tools for building ETLs pipelines. Next is, up to the minute data. Now, your data pipeline should be capable of constantly refreshing data in the data warehouse in order to keep it up to date. So you need to be able to stream data into the warehouses and not rely only on batch updates. Next would be the machine learning. Also, predictive analysis is becoming increasingly, important. So as a result, a modern data warehouse has to support machine learning without moving the data out of the warehouse. So that's one more point. Now, last but not the least, um, a modern data warehouse should be able to impose enterprise grade security. So that's about the modern data warehouse. Now, moving on to the next slide. Now, we are familiar with basics of BigQuery, right? Now, we'll just see how it's organized, how your data is organized. Now, BigQuery organizes data tables into units called data sets. See, these are the data sets. Now you have project X and project Y, and you have these data sets separately, and you have tables into it. So these data sets are scoped to your project, GCP project. Okay. Now, when you reference a table from the command line, or maybe SQL queries are in code, you refer to it by using the this one, project.dataset.table. Now, what are some reasons to structure your information into data sets, projects, or tables? Now, these multiple scopes, project, data set, and table can help you structure your information logically. So you can use multiple data sets to separate tables pertaining to different analytical domains, and you can use project level scoping to isolate data sets from each other according to your business needs. Okay. Now, apart from that, you can also align projects to billing and use data sets for access controls. You store data in separate tables based on logical schema consideration. So every table would have different, schemas, right? And you control them by placing them into different data sets. Okay. Now, the project is what the billing is associated with. Okay. Now, for example, if you query a table that belongs to BigQuery public data project, okay, the storage costs are billed to the data project. Okay, now to run a query, you need to be logged in, right, into the GCP console. So then later you'll run a query in your GCP project. So now the query charges are billed to your project, not to the public data set. Okay, so now in order to run a query in a project, you need cloud IIM permissions to submit a job. Okay, so now access control is through cloud IIM. and is that the data set level. It is in a data set level. Okay, not individual tables in the data set. See here, the permissions are given to the data set. You don't give permissions to the tables. That's what it means. Now, like cloud storage, BigQuery data sets can be regional or multi-regional. Now, regional data sets are replicated across multiple zones in the region. Multi-regional means replication among multiple regions. We have seen the multiple zones and multiple regions, right? So now, um, the permissions here, access control is to the data set we saw. Now, however, many other permissions are also possible. Okay, moving on to the next slide. Now we'll look at the access controls and costs. Now you can only control access to data sets. We know that, right? When you provide read access to a data set to a user, every table in the data set is readable by the user. Now, what if you want more fine-grained control? Now, that's when you use views. Okay. For example, in this, we are creating a view and a data set B. The view is a subset of table data in data set A. Okay, now by providing users with access to dataset B, we are creating an authorized view that is only a subset of original data. Now that you cannot export data from a view, and dataset B has to be in the same region or multi-region as the dataset A. So that's how you just give a fine-grained access. Now, about the cost, you can separate the cost of storage and the storage of queries by separating project A and project B. Now, it's possible to share the data without giving access to run jobs. Now, in this diagram, user 1 and user 2 have access to run jobs and access the data sets in their respective projects. Okay. If they run a query, that job is built to their project itself, own project. Now, what if user 2 needs the ability to access the data in project A? Okay. Now, this person who owns project A can allow access to this project user 2 to query the project A data set, and charges will go to project B. Okay. Now the public data set project owner grants all authenticated users access to use their data. Now authenticated users must use BigQuery within their own project and have access to run BigQuery jobs so that they can query the public data sets. The billing for query goes to their project even though the query is using public or shared data. Okay, so the billing happens to the project itself, though you're using the public data. So that's about your access control and the costs, about data warehouse. That's it for today. I think we'll continue in the next session with other few topics. Any questions, guys? If no questions, then that's it from my end. Thank you.